Hello everyone, a very good morning to you all and welcome you for the Math Everywhere event that the GEM Foundation, the Growing Young Mathematicians Foundation, organizes every month. This is Vidya Govindan, educator and the founder of the GEM Foundation. As I mentioned already, Math Everywhere event started with an aim to introduce how math concepts are related and applied in real life examples. And this event actually takes some examples from real life and help children understand how they are actually connected to the real life. And as part of this process, the children would develop interest, apply math concept in the real life, and get a better understanding and also get equipped for jobs of the future. So, in this Fibonacci sequence that we have been discussing in part 1, we covered who is Fibonacci, the Italian mathematician, the story behind Fibonacci, finding the interesting number sequence through rapid breeding, and when is the Fibonacci day celebrated in United States. So please do watch the part 1 of the series in order to understand a better context of what we are going to discuss in this part 2. The part 2 is just going to discuss about the Indian mathematician called Hemachandra who lived 50 years before Fibonacci in the year 1150, and how Hemachandra discovered the same number sequence while he was making combinations to figure out the tabla music notation that he is going to do. So let's see how this happened. So Hemachandra is a mathematician and also a tabla musician. So he know about the Sanskrit prosody. It is actually a study of the meter and the rhythm, a methodology of rhythms and also the arrangement of tones. And the Sanskrit prosody is actually called as Chanda Shastra. Chandas means a kind of a pleasing music or the pleasing way music is being structured so that it is remembered for a long time because of the rhythms and the structure of the arrangement of the tones. So in the Chanta Shastra, they just use two syllables, namely one beat, just one beat short syllable, and that is called lagu, and a two beat long syllable, and that is called guru. So just with these two syllables and the combinations of using this in different ways, there are so many rhythms which has been constructed. So tabla musicians use only these similar two syllables to make rhythms, namely a short syllable is called dhin and a long syllable is called dha. So I repeat, the short syllable, which is a one beat syllable, is called dhin, and the long syllable, which is a two beat syllable, is called dha. So how Hemachandra used this is an interesting story. So it appears that Hemachandra, the Indian mathematician and musician, was wondering how he could compose with these just two beats, having a lagu and a guru, or din and a dha, and if he has an 8 beat length music composition that he has to make, what are the different combinations that he could come up with, right? So the different combination, in the sense, if there is an 8 beat time interval, how many different combinations he can make using these just two syllables. So there comes this interesting pattern that he figured out, basically like this. So he started thinking how he could make different combinations and how many combinations using 8 beats. Let's say, for example, if there is only one beat, okay, we will do it like this: the beat and combinations, like the possible combinations, and how many combinations. So if there is only one beat, then the only possible combination that we could get, as we can see here, is din. So we'll have just din here, which is of one short syllable, and the combinations is only one. So here it is how many combinations. So if there are two beats, then you could have dhin din, which is a 1 1, or a dha, which is a 2. correct? So how many combinations? It is 2. And if there are 3 beats, so how would you do it? It is dhin, 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 which is like 1 1 1, or a dhadin, which is like this, dhadin, which is 2 1, or a dhinda, correct, which is 1 and 2. And how many combinations? 3. So similarly, if he could follow this, then he for 4 beats, then he could get all 4 ones, or 1 1 2, 1 2 1, 2 1 1, and 2 2. So totally 5 combinations. So based on this, he figured out that he is already having 1 2 3 5 8, and then 13, and it goes on. So based on this, he figured out that for 8 beats, how many combinations he can have. So basically, it would be like, for example, 1 2 3 5 8. So this is for 5 beats, and then 13, 21, 34. So 1 2 3 4 5 6 7 8. So for 8 beats, he can have totally of 34 possible combinations. Isn't this interesting to know how just by observing the pattern we could come up with new sequences and formulas? And as you might have already observed, this is very similar to the Fibonacci number sequence that Fibonacci figured out through rabbit breeding. And Hemachandra, even 50 years before Fibonacci, has actually figured out through his tabla music combination. And this is how children, all of you, even in your hobbies, if you make kind of small observations, you can figure out interesting patterns like this on your own. So please do observe the patterns in your hobbies. So now, who is this Hemachandra, and was there any reference to such sequence in Indian mathematics earlier? Yes, actually, the Chandra Shastra was pioneered by a scholar called Pingala from 2nd century BC, and he has also had made many references about this kind of a sequence in his works. And Acharya Hemachandra, the Indian mathematician and the Jain scholar, he has wrote an extensive commentary on this Chandra Shastra and how he applied it and used it in his tabla music. And there was one of this author of the book, The Butterfly in the Quantum World, has duly claimed that this Fibonacci series, which has now been known all over the world, should be called as Hemachandra Fibonacci sequence, because we have a very good record and also detailed notes about how Hemachandra figured this sequence and recorded it way before Fibonacci. And Manjul Bhargava, a Canadian mathematician, he is from Indian descent, a Fields medalist, is also taking efforts to spread this awareness on how these Fibonacci series has been originated in India, and how Hemachandra has figured out this sequence using his tabla music. So you can watch many of Manjul Bhargava's videos in YouTube to know more about this. And I hope that this kind of created an interest in you to know more about Indian mathematics, because Indian mathematics is not a separate subject. In the earlier days, it has been intertwined in many domains and also perceived as not as a subject but interdisciplinary, meaning in arts, linguistics, language related, astronomy, finance, in everywhere mathematics has been intertwined and is being taught. So we as students and teachers have the responsibility and also should have interest to see mathematics not just as a subject and solving problems, and go a step above and help and kind of figure out how these mathematical concepts are related in our everyday lives. How do we use them, and have an eye for the details and apply them in our real life examples. So with this, I thank you all for joining the second part of the Gym Foundation's Math Everywhere event. The third part of this series would actually cover an interesting part of how this Fibonacci Hemachandra sequence is actually being seen in nature. It is not just a number sequence. So stay tuned for the next session on how this Fibonacci number sequence is actually seen in nature. Thank you.